Hello everyone. Welcome back to Python Challenge for All. Okay, so last time we were trying to find perfect numbers, actually, with a very simple and naive algorithm, right? We tried to pick up the divisors of n using this list comprehension. And then if that's twice the number, twice of the original number, we call it perfect numbers. And we found that, we checked up to 20,000 and found that there are only four answers. Okay, let's continue to see if to find further perfect numbers, maybe we need to try to do it faster than this. So we will look into this problem of how how to do the work faster. So can you think of any wiser algorithm? Yeah, there is. Uh, we need to pay attention to the fact that the divisors almost always come in pairs. You know what I mean? Meaning, think of a case of 24. Okay, one is a divisor. At the other side, 24, which is 25 divided by 1, is also a divisor. 2 is a divisor, and at the same time, 12, which is, yeah, 24 divided by 2 is also the factor. 3 comes with 8. 4 comes with 6. And that's all, right? We don't need to check 6 because it's already in here. So that's the idea. So the idea is when I is a factor of n, append also q equals n divided by I. Okay, quotient of I. So let's implement that and check that. So this function is div1, kind of divs. So we will define another function, divs2, with this idea. Here, maybe list comprehension is not good. So let's define a list of divisors, list of factors, initialized as empty list. And then we will check for one by one for I in range from starting from 1. Again, we check until n. So I write n plus 1 here. And the idea is, of course, if n is divisible by I equals 0, then, of course, we say that I is a factor of divisor of n. So we add it. But at the same time, yeah, is from this idea, q equals n, quotient of n divided by I is also a prime factor. So let's check that. In this case, q equals n slash slash I is also a prime. So we can add it to q. Okay, this is the idea. Let's see what happens for case of, say, 24 and see how this works. Okay, there is none. What's wrong with it? I need to return L. Okay, L. So let's see what this means. So the problem is we'll make the two things twice or many times. So we need to stop watch out for the case of 23 or break from loop if I squared is greater than n. So one idea is um, if I squared is greater than n, maybe we can break. That's one thing. Okay? Let's see how it works. Oh, good, very good. So 124, 2, 12, 3, 8, 4, 6. Fine. To check it easier, because yeah, sorted um, this will help us check that faster. But anyway, this is fine. But let's see what happens in the case of 36. In case of 36, yeah, the problem is that we have two sixes here, right? Because, yeah, in case of two, yeah, six, yeah, six is already here, so we don't need, we we cannot append 6 here. So the point is append only if q is not equal to I. So here, instead of writing L append q, we should write if q is not I, append L. This is better. Let's check that. Okay, now we have only 1 6, which is fine. Okay, so it seems good. So let's check this algorithm to see if it gives this same answer. Okay, divs 2, sum of divs 2 is equal to the original k. Okay, let's check that and see how it works. Okay, good. Seems it was faster, right? So let's measure time and compare divs 1 and original divs and divs 2. Okay, to measure time, yeah, maybe you know how to do that. We import, yeah, here maybe, we import time package and then stime equals time dot time function. And after doing everything, we print um, elapsed time. Okay, f time plus time is time dot time, the present time. Maybe we can do this out before that. Okay. Um, E time, elapsed time is time dot time minus S time. This will help us measure the time required for this computation. So here we do E time colon dot 2F will help us write in, yeah, maybe 1F is enough. But okay, 2F. Let's measure time for the original one. Oh, div is not defined. Sorry, we need to run this. And we can run this. Okay, running. Good. In the meantime, we will do the same thing for div 2. Copy this, paste here, and change divs to divs 2. Okay, after we finish this, okay, 14 seconds, 14.34 seconds. Maybe I should write S here. Okay, here again, I write sec, and then run it. Oh, marvelous. 0.3 second. Only 0.3 second compared to 14.3 seconds in the original case. So this makes a much big difference. Okay. Um, let's see. Okay. So this shows checking up to 20,000 there's a big difference of 14 seconds versus zero point 0.3 seconds. Okay, now if you go further, up to say 10,000, of course the difference is much big. Hmm, maybe next time we will try to plot and compare. Can you try it yourself using matplotlib? We done this before, so you can try it. We'll see the results. We'll compare our results next time. Okay, so be sure to come back. That's all for today. Bye bye.